In this example, we want to simplify using the properties of exponents, also known as the rules of exponents. And let's try part A. We have a squared b times a to the 13th b to the 17th. So let's get a little bit of notation down first. When you have something like 9 to the 7th, right? Something like that. This bottom part here is called the base. Okay, and then the part up here is called the exponent. Okay, and one way to look at what these mean is, you can think of it, it's not an entire way to think of it, but something like 3 cubed is 3 times 3 times 3 times 3, 27. So that's one way to think of at least when you're getting used to these exponents and bases, what they mean. And then we have all these wonderful rules or properties that help us make progress with understanding these. This first rule here, a to the m times a to the n equals a to the m plus n. So when you have two situations here with the same base multiplied together, you add their exponents. That's a very useful rule, but it's easy to confuse with the second rule here when you have just a single base and an exponent, and now it's taken to another power. So we have a to the m all raised to another power. So we're raising a power to a power. When that happens, you multiply together. So base times another base, add the exponents. Base to a power taken to another power, multiply them together. Okay, when you have a times b here and you're taking both of these to the power of n, this n distributes through to both of the bases to give us a to the n times b to the n. Now it's easy to confuse this one, tragically, with another very similar looking situation, a plus b to the power of n. That does not equal a to the n plus b to the n. So make sure you can spot the difference between these two situations. When these are multiplied together, the n distributes through to both of them as the exponent. When they're added together, the n does not distribute through. If you did want to do this, you would use a to the n plus 2ab plus b to the n. Okay, so that's how that goes. But when they're dividing, great, it works out really nice. The n just goes through to the a and to the b, kind of comes out like we'd expect, a to the n over b to the n. When we're dividing like this, though, when we have a to the m over a to the n, we subtract the exponents. So this rule goes along nicely with the first rule, right? These kind of go together. You could think of it that way. When you're multiplying the two bases together, you add the exponents. When you're dividing the two bases, you subtract the exponents. So that's a nice way to remember that property there. And this last one is just some general facts about exponents. Anything taken to the power of 0 is 1. As long as a is not equal 0, I'll just say that as a little caveat there. And then a to the 1 equals a. So anything taken to the power of 1 gives that thing back. Okay, so there's those rules of exponents. You should internalize these, right? They'll be used often as you go through and study mathematics. So let's apply these to an example here. In part A, we have a squared b times a to the 13th b to the 17th. I'm going to rearrange these a little bit. So I have a squared. Since it's multiply, we can do this with no problem here, just moving things around. We don't really need these parentheses at all. So a squared a to the 13th times b to the 17th. Well, anything, when you just have a b, it's actually b to the 1. That's the same thing. Any number by itself is that number raised to the power of 1. So now I'm looking at using this first property up here on both of these. Right, I'm using this property. So here we have a to the 2 plus 13, b to the 1 plus 17. All right, we use it on both a and b. Now we simplify it down. A to the 15, b to the 18. There we go. Now we can't combine a's and b's because those are different bases. When they're different bases, they don't play well together. You leave them separate. Okay, for b we have quantity x to the 4th y all raised to the power of 7. So here I have a a 7 outside these parentheses. So I'm going to begin using this property here that tells us to take the exponent and distribute it through to both those terms. So this gives us x to the 4, now we're raising all that to the 7, times y to the 7. Well, this y to the 7 is taken care of, but now for x to the 4th to the 7, we're taking a power and we're raising it to another power. So I'm going to use this second property here, and that means that we multiply the two powers together. The two exponents, we'll say. Exponent and power mean the same thing. So here we have x to the 4 times 7, y to the 7th, which leaves us with x to the 28, y to the 7th. There we go.